Hello guys, in this video we are going to discuss the solution of the problem insert and search in a trie. So let us look at the problem statement. Complete the insert and search function for a trie data structure. Insert accepts the trie root and a string, modifies the root in place and returns nothing. Search takes the trie's root and a string, return true if the string is in the trie, otherwise false. And to test all these things, okay, this is fine. So let us try to understand the problem statement, or rather here we have to understand the trie data structure and then we have to write functions for insert and search operation. So let us understand the trie data structure first, and then we will look how we can perform um, insert and search operation in a trie data structure. Okay, so the trie data structure is an extension of tree data structure. Okay, extension of tree data structure. So as you know, in tree data structure there is a root, right? So there is a node and there could be at most two children to it, right? This is basically its left child, and this is its right child, right? So in trie data structure, what we do is basically instead of having two children, a node will have multiple children. Or more specifically, in trie data structure, a node will have 26 children. Okay, all the way till 26 children. Alright, so this is children number 1, this is children number 2, 3, 4, and all the way till 26. Let's start from 0. Okay, let me just write down the right from 0. So 0, 1, 2, 3, and all the way till 25. So 26 children would be there for a trie data structure. Okay, and each node will again have 26 children. So let us say this node and this node will have 26 children. Okay, again here 0, 1, 2, and all the way till 25. So what basically happens here is this node we will use if the word which we want to store contains a, okay, or it starts with a. We will look, I'll take a concrete example and I'll try to construct a trie data structure. This node will be used if it contains b. Similarly, this is c, this is d, and all the way till z. Okay, so that is why this will have 26 children, because the letters ranges from a to z is 26. Similarly, here also it will range from a, b, c, and all the way till z. Okay, so that is how the trie data structure will look like. So let us take an example. So now let us see, we want to store the word the in trie data structure. So the way the trie data structure will look like is, we will have our root node. Then this root node will have various children, of which as of now only t is relevant. So t it will have. So the node or the child which corresponds to t will be active, or it will have a node, and this will be that node, right? Now after t there is an h. So again this will have multiple children, but all the children will be null initially, and the one which we want to use, which in this case is h will be active, and there will be a child associated with h. Okay, now let us say there is another letter we want to store, which is e. So again the same thing, e will be here. Okay, and once we have completed this entire one word, when we have completed one word, or once we have represented the entire word in a trie data structure, the last node, right? So the eth node, what are we going to do is basically we are going to mark it as true. Okay, So I'm just drawing it as here. So this is basically true. Okay. So like the trie data structure, if you see the trie data structure will contain first it will contain children, self dot children, and there are how many children it could have? Well, it could have 26 children, right? 26 children, and it will have something called as is end of word. This is a bool, and initially its value will be false. Okay, so this is the data structure. Now the is what we wanted to store, so t we did it, and end word is false. Similarly h we added it, and e we have added it. Once we have completed e, then we are setting this particular field to true, and this is what I am trying to represent like this. Okay, now let us say there is another word which we want to represent, which is them. Okay, so the way them will be stored here is the is already there, but m we want to store, so this will be extended further and we will have it over here like this, and m, and since this is also the end of it, so we are going to set it to true, right? So true simply means this is the end of the word. All right, now let us say there is another word which we want to store, and let us say that word is uh, wax, wax, wax. So now so on the first layer t is there but w is not there, so we are going to create a node for w, then we are going to create a node for a, okay, and then we are going to create a node for x. Okay, and now since this is the end of it, so this we are going to set it as true, right? So that is how we are going to perform insert operation, or that is how we are going to create a trie data or a trie tree or a trie data structure. Okay, now let us see how do we perform a search operation in it. So let us say we want to search wax in this trie data structure. So first we will see whether the first letter here, the first letter is w, where w exists, or root, from root can I make a transition to w or not, right? Since there exists a child corresponding to w, so w exists. Once we are sure that w exists, we will see whether a exists or not. We see that a exists, right? Then we will move forward and we will check x, whether x exists or not. Once we are sure that x exists, and then we have to see whether x is the end of the word or not, and whether x is the end of the word is not is something which will be checked via this particular entry, right, which is true, which is end of the word. If it is set to true, then we are going to return true, that the word exists in the trie data structure, otherwise we are going to return false. Okay, now let us take one more example. So let us say we want to search for ant in this trie data structure. So clearly we will be looking for a, and here there isn't any transition from a, so because of which we are going to return false, stating that this word does not exist in the trie data structure. Let us take one more example just to conclude it. Let us say we want to look for the word th. Okay, just the word th we want to see. So here t exists and h exists, but once we have completed the word th, this does not correspond to the end of the word, right? This node is not the end of the word. Now that simply means that this word is not there in the trie data structure, because of which we are going to return false in this particular case. Okay, so that's the explanation, folks, of the trie data structure. Now let us see how we are going to code it. So I have already coded it. Now let us look at the code for it. So for insert, what we are going to do is that we are going to take current node and we are going to set it as root, and then we are going to iterate on each of the letters of the key. Okay, each of the letters of the word. Now first we will check whether that letter or the transition, so from root, do we have a child corresponding to that particular letter or not? None simply means that there isn't any child, or that letter has not been added into trie data structure yet. Okay, now since we have to add that letter into trie data structure, so we are going to create a new node and we are going to append that, or we are going to uh, make a transition between current node dot children, and which children. So this is basically like, I hope this is clear. Like this is basically so this children is from 0 to 25. 0 represents A, B, 1 represents B, and so on till Z. So let us say if I want to make a transition from from current node to A, so A minus A is equals to 0. So that is how B minus A will be equals to 1. So that is what I am doing here. So the current node dot children, I'll make a transition and I'll put new node over there. Okay. Once I have done that, I am updating my current node to the next node. Once after doing that, once I have inserted the word in the trie data structure, the last node I'm going to set it to true. Okay. So that's about the insert operation. And now let us look at the search operation. So the search operation goes in the same way as the insert operation. It is just that we will be looking for whether there exists a transition from current node to the word or to the letter which we are at. If there isn't exist any transition, that simply means we don't have that, or we don't have that word. If there exists a transition, then we will say okay, fine, we there exists a transition, and then we'll move to the next letter. We'll compare in this way. We will be comparing all the letters. Towards the end of it, we will check whether my current node is the end of the word or not. If it is not end of the word, we are going to return false. Otherwise, we are going to return true. All right. So that's the code, folks. Now let us submit our solution. So our solution got accepted. So that's from this video, folks. In case if you have any question or queries regarding this video, please feel free to use the comment section and I will try to address them. Thank you.